July the 2nd, 2022 is Liverpool Makefest, one of the largest mixed electronic and creative arts exhibitions to be held here in the UK. And myself, as Wi-Fi Sheep, has been invited thanks to our TinyBASIC Computers project. Hello and welcome back to TinyBASIC Computers, the homemade 8-bit programmable computer series from youtube.com/Wi-Fi Sheep, where we're building easy to assemble, low cost, real programmable computers. If you're brand new to Wi-Fi Sheep and this project, then do check out the TinyBASIC Computers playlist, which has all the projects so far. Last time we just ordered and built the revision 2 PCB version of our TinyBASIC computer system, and I had already made a couple of adjustments, mainly the use of a twin RCA phono plate in place of the two BNC jacks used in the original design. This was done in readiness for a 3D printed case solution for the PCB. Then, last year, after the project was exhibited at the Preston Makefest event, I was invited to showcase TinyBASIC computers at Liverpool, which at time of recording is under 2 weeks away. Details of the event can be found by visiting events.wifisheep.co.uk. Now, before we continue, a quick reminder about our project sponsor, PCBGoGo.com, who have been instrumental in assisting myself and making TinyBASIC computers possible. PCBGoGo manufacturing bases are equipped with the most advanced production equipment such as Yamaha pick and place machines, reflow ovens, wave soldering machines, X-ray and AOI testing machines, all operated by highly skilled technical personnel. Their factories and world-class production facilities have over 10 years of experience in the PCB industry, serving Chinese domestic and internal markets. PCBGoGo is a leading specialist in surface mount through-hole and mixed technology PCB assembly and electronic manufacturing services, as well as turnkey electronic PCB assembly. PCBGoGo provides easy and cost-effective online ordering services from prototype to mass production. So join today. Sign up for your free account today at PCBGoGo.com. So this is where we left off last time with the revision 2 of the TinyBASIC Computers PCB. And unlike the revision 1, I made a couple of modifications where I added this phono or twin phono plate and wired it onto the back, as opposed to using the BNC connectors that the board was designed for. That's perfectly fine and it works fine. So, as I mentioned in the intro, this is what we're going to be presenting at Liverpool Makefest 2022. But I wanted to do a bit more than just bring a kind of a blank or, plain PCB like this. I wanted to create something that was a bit more exhibition worthy for the public. And I did think about printing or encasing this in a 3D printed plastic case. Something a little bit like this. So these are cases I was doing for another project, and they were originally designed for Raspberry Pis, but I thought I could modify that. And I thought you could actually encase the electronics inside plastic, which was fine. But then I thought about it, and the whole point of the Makefest, and I suppose in a way the whole point of the TinyBASIC Computers project, is that we want to see the electronics actually that makes the computer work. And if you sort of put this board inside this case, for example, then you kind of just create a mystical box of magic that no one really understands what's going on inside. So this, although pretty cool and still something I might do, is not the approach I want to take for the exhibition. So, back to the plain board, and I thought about, well, what about the idea of creating some sort of open plan modular system that allows components to be sat together, because I do want to expand on this and add additional boards and components to this build. And I thought, well, what about a kind of a modular system? So in CAD, I started mocking up the idea of kind of almost a clip together pegboard type arrangement using 3D print or custom 3D printed parts. So I created this baseboard with these peg holes, and then I drew up some adapter plates that would fit the screw holes of things like Raspberry Pis, the phono mounts, and of course the TinyBASIC PCBs, where I fitted the screw holes here on revision 2s. Went over to my trusty Flashforge Finder printer. That's the red one that sits in the corner of the room when I'm normally doing intros. And yes, it does get some work. The machine is way past its best at the moment, but it's a real workhorse. And I printed out a chassis plate in black. This is all in PLA plastic, by the way. It's a bog standard PLA plastic. And I thought for the adapter pieces I would use a sort of yellow. So we'll go for a yellow and black theme. And here is the result. So this is the 3D print plate. Now, it's been printed in pretty much a draft quality and it's not perfect. I've been having to rush these through, unfortunately, quite quick. So I just want to sort of mock a prototype up. But this is the kind of baseboard. And then I've got these two peg-based adapter plates. So that one is for the RCA phono jacks. And this one is the main screw mounting plate for the PCB. And I just have these pegs in the bottom. And they just sit into the board pretty much like that. Now I've got some screws and some bolts. These at the back, the phono technically takes, I think it's M2.5s, although M2s will do fine. And I believe the TinyBASIC computer's board, if I remember correctly, it's the same as the Raspberry Pi, so I think they're M2s, but I will check that. But yeah, so I've just got 4 self-tapping pin screws, and then I've got 2 nut and bolt arrangements. So this is really simple. It just clips in, also sits like that. And I'll just grab a crosshead screwdriver. Make sure we line up correctly. There we go. And the board will fit in like this, and then it just creates a nice sort of plate, if you like, to present the computer on, while still keeping it all open so everyone who's at the show can see, you know, what parts actually make this machine go. And now for the phono. Now, when I designed this, I decided not to put a... Just take that back out a minute. I decided not to put a crossbeam in because you may, like me, have already wired up your RCA jacks. So you've already got the cables, and if I put a crossbeam in, you'd have to unsolder something to feed the wires through, and that's really annoying. So I thought ease of use for what we need to do. Let's plug that back in. So we can just put the plate like that. And then we can put the bolt through. That's on the end. And I'll get a pair of pliers and a screwdriver on that just to tighten those up. And it really is as simple as that. That's basically what I want to present at Liverpool. One of the many things we're going to present. We're going to have the breadboard machines. We're going to have the original 6502 breadboard project as well. So well worth coming along if you can. It's going to be on July the 2nd. 2022 at Liverpool Central Library. Full details you can go to events.wifisheep.co.uk. Now, the plan for the exhibition is to run this particular unit in this configuration via composite out. Going to have one of the retro black and white CRT mini CRTs. They're impractical to run, but they look cool, and I think it's worth taking one. And we'll have a PS2 USB keyboard on the front, and this thing will be running self-contained. And the plan is it's going to run the simple guess the number basic game that you've seen before in the series here on Wi-Fi Sheep. And it was working fine until around February, where someone looked at the source code for it. It's a very simple program. It sits at about 200 bytes of RAM. Someone was looking at the source code, and they stated there was a bit of a glaring error, which was when the computer guesses a number, uses the random statement in BASIC, guesses a number, puts it into a variable, and you have to use input statements to guess the number. every time you get it wrong and it loops the program back, it resets the number it's thinking of. So the number you might, for example, put 7 in and it says no, but then it will reset what it's thinking, and it might think 7, but you don't realise it's changed, and so you're not going to press 7 again. So there's a bit of a glaring error there. Also, I realised it doesn't have a play again reset script. So what I'm going to do is we're going to make a few changes to the program that's stored in the EEPROM, which is there. And we could do that just by booting this up and typing and changing it in BASIC. This is a standalone computer that will work. However, it sometimes is a little bit easier if you want to dabble around with code to use an external editor and plug this in to an external machine, such as a trusty Raspberry Pi 400 running the stock Raspbian Linux. And you can remote control a TinyBASIC computer quite simply with a USB. So it's mini USB in there and full-size USB into the back of the unit. We'll get the rest of this powered up. This will then power the machine, and we can remotely control the TinyBASIC system from a Raspberry Pi. We don't need to plug anything else into this side of the computer. Okay, so we're all booted up. This is a stock Raspbian, and our TinyBASIC computer is plugged in via USB. So it's powered up from the USB and it's attached to the computer. If we go to terminal, and on this particular Pi, I've loaded a terminal device called Minicom. Just look it up online. It's Minicom and how to install it on the Linux Raspberry Pi. And I already have a preset here. So Minicom, and it's -B, which is for Bard, 9600-O-D, and then it's /dev/tty USB 0, which is the USB port. And if we enter Minicom, there we go. And you can see here that version 3.0 alpha of TinyBASIC has loaded. That is now the output, the UART serial text output from the BASIC interpreter running on the board. So this is another way of remotely accessing and controlling our TinyBASIC system without actually needing to plug a keyboard or a monitor into the physical computer. So the program in question, let's just go to, here we are, guest name 2. Now this is just a text file. It's opening in, is it Leaf, what is it, a mousepad? Used to be LeafPad, mousepad on this. So this would open in TextEdit on a Mac or Notepad, WordPad on a PC. Basically, it's just a generic ASCII text file. And here is the source code and the modifications I've made. So basically, it's still the guess the number game. And we input n. So first of all, 40, x equals random 10. So it's picking a number 0 to 10. And input n. If n equals x, x is the random number, then it's correct, go to 90. If it doesn't, nope, try again. And again, if it doesn't, go to 50, back to 50. So instead of going to 40, which is doing last time, and it was just resetting the number, it just goes back to n, and we keep looping until you get it right. If you get it right, it jumps to line 90, which is new game. This is a new part. Now, normally with computers, new game would be n or y, n for no, y for yes. This version of TinyBASIC can't handle text-based strings, so you can't actually enter a letter, only understand and enter numbers. So option 1 would be y, and option 2 would be n. So input n, and if n equals 1, which is yes, go to 10. If n does not equal 1, which is basically any other number, would equal no, no would end the program, yes would go right back to the beginning and would start again. So I've written this in a modern editor, and I can just select, copy, and if we type new into our TinyBASIC session, and we can paste, that'll paste the code straight into the computer. If I now list, there is the code in memory, and I can go save, and that will save it. And we can run. So I'm thinking of a number between 0, 10, nope, try again, 10, nope, 2, 1, 3, 4. Okay, it was 7. So now it says, do you want to go new game? Yes or no. I'm going to say 2, no. and it ends the program, and we're back to the basic prompt. So that's basically all I want to run on this. I might make a few modifications, such as putting the sound command back in, because I stripped it out originally because it was used for the EduCraft commercial version, or the licensed version I should say. But I think for this it might be nice if it actually has some sound back, so I may put a sort of two-tone sound command back in. But fundamentally that's it, and that will now work. I will update the final source code shortly to the Patreon-based TinyBASIC Computers Toolkit, where you'll be able to get hold of all the latest stuff I've been working on. Okay, so I'm disappearing on the cabling here, but I just thought I'd take a moment just to demonstrate the improvement I've made to the sound system. So I've added sound to the guessing game as well. I've plugged in one little CRT I plan to use, and it's also got sound plugged in. So the sound from the CRT is going to sound better than the onboard buzzer speaker. Anyway, let's run the program. So we should be able to go E-chain. There we go. And guess the number. So you can also got a nice deep sort of buzz sound for no. There we go, 7, correct. And now we've got a new higher pitch tone if I'm correct. And then it says correct, new game, 1 equals yes, 2 equals no. So I'll say yes, that's new game. Guess the number again, what number I'm thinking, and we can just rerun the whole thing again. There we go. So it was 9 that time. And I'll say 2 for no, and it returns to the OK prompt. And yeah, so that's working really well. So we have one TinyBASIC system ready to go. Of course, one computer isn't really enough for an exhibition, so I plan to show a few other builds at the MakeFest in July. Some, like the original 6502 breadboard build you've seen before, and others, like Ping Pong and Colour System, are coming up here on the channel real soon. If you can make it to Liverpool, do come and say hi. The event is free and happening on July the 2nd, 2022 at Liverpool Central Library. Links and details see events.wifisheep.co.uk. If you want more information and access to the free downloads for our TinyBASIC Computers project, then do join the free Facebook group at facebook.com/groups/WFS TinyBASIC. And as previously mentioned, $3 plus backers on patreon.com/WiFiSheep can take full advantage of the TinyBASIC Computers download toolkit, which now includes the Gerber files for ordering your own custom TinyBASIC PCBs. All this and more can be found at patreon.com/WiFiSheep. If you've not done so already, please do consider liking and subscribing. And as always, thank you so much for your company, and I hope to see you real soon right here on the channel. Until next time, bye for now.